Okay, scholars, so for part two of this lesson on using word problems with linear functions, we're going to do three more examples of taking a word problem and modeling a linear function for it. So, with example four, you are 325 miles away from home and are driving home at a rate of 55 miles per hour. Write an equation for the distance y you are from home after x hours. How far are you from home after 1.5 hours? So again, first rule of the business is to read the problem. Now that we've read the problem, we annotate and we go through the problem. So you are 325 miles away. So you are starting 325 miles away. So you're starting 325 miles away. And you're driving home at a rate of 55 miles per hour. So 55 miles per hour, that is a rate of change. Now, keep in mind, you're going home. Now, the key part here is that you're going home. You're 325 miles away and you're going home. So when we get ready to set up this equation, you're trying to get to your house. That means you're reducing your distance. So when we set this up for the equation, 325 miles is where you are starting from. So that means your y-intercept is 325. 55 miles per hour, you're going towards your house. So that means your slope would be negative 55. Because you are decreasing your distance because you are going home. If you are going away from your house, then it would be a regular 55 because you're extending the distance from your house. So you have your slope of negative 55 and you have a y-intercept of 325. So slope and y-intercept is already perfectly set up to write your equation. So you do not need this formula. You don't need point slope form because you already have the slope and the y-intercept. You can go right to y equals mx plus b and substitute in your values. Negative 55x plus 325. So that's the first part of the problem. You have your equation. That's not everything they asked for. How far are you from home after 1.5 hours? So they told you that x represents the number of hours. So 1.5 hours means that x equals 1.5. So that means y equals negative 55 times 1.5 plus 325. So now that you have that, you're simply using the calculator and computation to solve out the rest of the problem. That's negative 82.5 plus 325. So you are 242.5 miles from home after 1.5 hours. So take that for what you wish, whether you're making good time, not making good time, whatever the case may be. But that is how you would work out example number 4. So in that case, you're given the slope and the y-intercept, which is the easy case for setting up the equation. So example 4 in the books. Let's look at example 5. One of your friends gave a recommendation for a caterer that charges $22 per person served. She did not know the initial cost for the caterer, but she did know that a party of 45 guests had cost $1,200. Write an equation that models the total catering charge y in relation to the number of guests x. How much is the original amount for catering? How much would it be for 80 guests? So there's 3 things that they're asking you for. They're asking you to write the equation. They're asking you how much is the original amount, and they're asking how much it would be for 80 guests. So there's 3 parts to the problem. So we read the problem. Now let's go back through it again. The caterer charges $22 per person served. So there's your rate of change. So $22 per person. That's a rate of change. Anytime they tell you it costs this much per something, that's a rate of change. She did not know the initial cost. So remember, initial cost is an indicator of the y-intercept. So as far as the y-intercept goes, you don't know that. She did know that a party of 45 guests, it cost $1,200. So 45 guests is $1,200. So now that we've gone through some more of the problem, total catering charge represents Y. So now you know that 1,200 represents a Y value. The number of guests is X. So 45 is an X value. Rate of change is also known as slope. So you know the M value. So you know the slope, you know an X value, and you know a Y value. You know a slope, you know an X value, you know a Y value. So that means you're not going to use Y equals MX plus B yet. You can't start with Y equals MX plus B. Rather, you're going to start with Y minus Y1 equals M in parentheses X minus X1, that are known as point slope form. So you know the slope, you know an X value, you know a Y value, you start with point slope form. So again, telling the difference between the two means you have to read the problem. You have to read the problem, you have to interpret what it's asking. So now let's actually do some work. So, first Y, remember, doesn't get touched. The second Y is 1,200. The slope is 22. The first X doesn't get touched. The second X, you plug in on 45. So far, there's our initial setup. Now we solve out the problem. So solving out, since we have the parentheses, we're going to distribute. 1,200 equals 22 times X is 22X. 22 times 45 is 990. And then to get Y by itself, you add 1,200 to both sides. That gives you Y equals 22X plus 210. 22X plus 210, so we now have our first, the answer to the first part of this problem. We have the answer to the first part of the problem. So we wrote the equation. Second part of the problem, how much is the original amount for catering? So the original amount is the initial cost. How much does it cost you for catering if no one shows up? How much will you have to pay the caterer if no one shows up? So the original amount is equal to that initial cost. And an initial cost is the same thing as a y-intercept. So that is equal to $210. So you are paying the caterer $210 regardless of anyone showing up. The caterer showed up, you're paying $210. That takes care of the second part of the problem. How much would it be for 80 guests? So instead of 45 guests, we want to know how much is it for 80 guests. So instead of X equaling 45, you're going to make X equal to 80. So for 80 guests, that's Y equals 22 times 80 plus 210. Let the calculator do some work. 22 times 80 is 1760. 1760 plus 210 gives you $1,970. So it will cost nearly $2,000 to serve 80 guests. Nearly $2,000 to serve 80 guests. So there's your 3 parts to that problem. So you're setting up the equation, identifying your initial costs, and then finally answering a related question to it. So again, it's not a difficult problem. It is a problem that you do need to read it carefully, and then pay attention to what you're doing. So lastly, number 6. The cost of taking Uber from the airport is a linear function of the distance being traveled. If you are going 10 miles, then the ride will cost $22. However, a 20-mile ride will cost you $38. Write an equation that represents the cost of an Uber ride from the airport based on the distance. Then find the cost of a ride if you need to go 25 miles. So, of course, if you've ever rode in an Uber, a Lyft, any kind of ride share, how much you pay is based off of the distance you're being taken. Now, most of the time, a ride to the airport is going to cost the most, not only because of the distance, but because of the congestion from the airport. But for this example, we kept the numbers relatively light. So notice in this problem, they did not tell you what X was and what Y represented. However, if you remember, when you are identifying X, you're looking for what do you have control over. What part do you have some control over, which in this case, you can control the number of miles you go. You can't control how much it costs, but you can control the number of miles. So we're going to make X the number of miles and make Y the cost. Yeah, you can control how many miles you go. You can't control how much it's going to cost. So if we look at the problem again, you go 10 miles, it costs you $22. So 10 miles will cost $22. 20 miles, $38. 20 miles, $38. So notice that we have 2 X values, 2 Y values. You do not have, in this case, a slope. You are not given a slope. You are not given a rate of change. So that means you are given 2 points, 10, 22, and 20, 38. So you're given 2 points. So it doesn't make the problem harder. It just means that there's one more piece that you got to find in order to start solving. And that one piece is the slope. So that piece that you need to get go and get first is the slope. So let's do that first. So slope formula, reminder, is y2 minus y1 over x2 minus x1. So 38 minus 22 over 20 minus 10. 38 minus 22 is 16. 20 minus 10 is 10. 16 divided by 10 is 1.6. So 1.6. So in other words, it costs $1.60 for every mile you're going to go. $1.60 for every mile. So now we know what the slope is going to be. We know the slope. Now we pick a point. Remember, you can use any point that you want. I'm going to choose the first one to put in 2-point slope form. First y you don't touch, y minus 22 equals 1.6. First x you don't touch, x minus 10. You go ahead and distribute. So y minus 22 equals 1.6x minus 16. Add 22 to both sides. So y equals 1.6x plus 6. So there's your equation. So there's your equation for this Uber ride. There's the equation for the Uber ride. So now let's put this into context. So if you have y equals 1.6x plus 6, so it would be 1.6 $1.60. That's your rate of change. That's how much it's going to cost you per mile. The $6, that is your initial fee. That's your initial fee. Now, for some Uber drivers, Lyft drivers, suppose that you cancel, that initial fee is pretty much your cancellation fee. Your initial fee is your cancellation fee. So we have the equation. They ask you to find the cost of the ride if you need to go 25 miles. So number of miles, remember, is x. So that means for our equation, for 25 miles, that's y equals 1.6 times 25 plus 6. And again, we let the calculator do its work. 40 plus 6, $46. So an Uber ride of 25 miles, $46. Which again, depending on where you're located, depending on where you're going, Uber rides fluctuate. So it all depends on the situation. But with that being said, we now have completed the 3 additional examples for writing linear functions for word problems. Again, I'm not going to say that writing functions for for word problems is easy. However, it only gets easier with practice and committing to doing the work. It only gets easier with practice. With that being said, use this video as many times as you need it. If you have questions, please feel free to ask. Otherwise, take care and have a good one.